So today we're going to talk about something that's a genuine game changer in medicine. It's about fighting brain tumors, but with a tool you might not expect. A much smarter, much sharper kind of AI that can find clues the human eye might just miss. Let's dig in.
And to really get why this is such a big deal, you have to start with this number, 28,000. That's roughly how many new brain tumor cases pop up every single year in India alone. It's a massive challenge, and for every single patient, the absolute best shot they have is finding that tumor early and knowing exactly what it is.
Which, of course, leads to the big question, right? How can we actually get better at this? How can we use technology to see things that are almost invisible and do it with near-perfect precision? Well, this is the exact problem a team of researchers decided to go after.
Now, the answer, as you probably guessed, is artificial intelligence. But I want you to think of it less like some cold, calculating robot and more like a digital detective, a specialist that we can train to scan medical images and hunt down the tiniest, most subtle clues that point to a tumor.
And the specific tool for this job? It's called a convolutional neural network, or CNN. The cool thing is, it's an AI that's basically inspired by how our own brains process what we see. Its whole job is to look at images, in this case MRI scans, and just get really good at spotting patterns. Kind of like a detective learning to recognize every little clue at a crime scene.
So, we've got our AI detective. Problem solved, right? Well, not quite. See, it turns out that a standard, kind of off-the-shelf CNN is, well, it's good, but when you're talking about a diagnosis that could change someone's life, good just doesn't cut it. The results can be pretty suboptimal, which is a fancy way of saying they just aren't accurate enough.
And yeah, this chart, it really paints a picture, doesn't it? When you look at older research, other methods hit around 72% accuracy. But some standard CNNs, they actually did worse, clocking in at just over 67%. I mean, that's a 1 in 3 chance of getting it wrong. That's a massive room for error, and that's just not acceptable. Okay, so this is where it gets really interesting. The crucial idea here isn't just using AI, it's all about how you train it. This research is all about taking that pretty good AI detective and putting it through this incredibly intense, elite training program to make it a true world-class expert.
This quote from the paper really gets to the heart of the problem. A CNN has all these little internal settings, these hyperparameters. You can think of them like dozens of tiny, super-sensitive dials on a complex machine. If those dials aren't tuned just right, the whole system just doesn't perform well. And trying to tune them all by hand? It's pretty much impossible.
So what did the researchers do? They came up with a pretty brilliant solution. They used other AI algorithms to automatically tune the main AI detective. It's like bringing in a team of legendary coaches to fine-tune every single muscle, every single reflex of your star athlete until they're perfect.
So let's meet the coaching staff. The researchers actually used 3 different optimization algorithms, and each one has its own style. You've got simulated annealing, which is kind of like a patient blacksmith, carefully heating and cooling the model to find its absolute strongest form. Then there's differential evolution, which works kind of like natural selection, breeding the best solutions to create an even better one. And finally, harmony search, which acts like a musician trying out different notes to find the perfect, most effective combination.
And the whole process is really elegant. You start with just a basic CNN. Then you hand it over to one of these AI coaches. That coach then runs tons and tons of simulations, tweaking all those tiny dials until it finds the absolute best, most optimal setup. And what comes out the other end is a brand new, hyper-optimized model perfectly tuned for the mission.
All right, so you've got your 3 new elite AI detectives, each trained by a different super coach. What do you do next? Well, you have to put them to the test, right? You have to see which one is actually the best. So that's what the researchers did. They pitted the 3 models against each other in a head-to-head competition.
And here are the results. Now, they measured a bunch of things, but the number everyone was watching was accuracy. And while all the models did pretty well, one of them just absolutely blew the others away. The model that was trained by simulated annealing, the SACNN, it achieved an accuracy that is just staggering.
Honestly, this result is so important it really deserves its own moment. We're not just talking about a small improvement here. This is a massive leap forward. We're talking about something that gets incredibly close to perfect for this kind of work.
Just let that number sink in for a second. 99.63%. In a field where, 70 or 80% was considered pretty good, this is a mind-blowing result. It means you have a model that is unbelievably reliable at telling the difference between a scan with a tumor and one without.
And this is the chart that tells the whole story. On the left, you've got that standard CNN struggling down at 67%, and on the right, you have this new super-trained model. That is the difference between just getting by and absolute peak performance. This is the power of training AI the right way.
So what does a number like 99.63% actually mean for real people? It means we are so much closer to having a tool that can help doctors make diagnoses that are earlier, more confident, and way more accurate. It's about getting rid of the uncertainty, catching these things sooner, and ultimately saving lives. This is where the code really makes a difference in the clinic.
So, what's the big takeaway here? Well, first, AI is obviously an incredible tool for medicine. But second, and this is the real secret sauce, the magic isn't just the AI itself, it's the smart way you train it. This idea of AI coaching AI, that's what's pushing us toward a future of automated and unbelievably accurate diagnoses.
And that just leaves you with this final kind of awe-inspiring question. If we can build an AI that basically teaches itself to be nearly perfect at one of the hardest jobs in medicine, what else could we use it for? What other diseases could we find earlier? What other medical mysteries could we solve? The future possibilities here are just extraordinary.